Hello, my name is Charles Martinez. Today's date is October 16th. This is approximately 2 p.m. And in today's attempt, I will be doing Circ 04 Attempt A. And in this attempt, I will be programming the timing of the servo motor to make it spin. And they wanted us to do the timing without using the library of the servo library. So pretty much manual programming, and my servo motor would not run with the code provided by the Circ 04 PDF instructions guide. Because my servo motor runs off of a pulse, I had to use a PWM code. A PWM pulse width modulation signal is a series of repeating pulses of variable width where either the width of the pulse or the duty of the cycle of pulse train determine the position to be achieved by the servo. So since my servo motor was pulse width modulation type of motor, I had to use a PWM code pretty much to not use the servo library. And I'm going to be going over the coding here. As far as declaring variables, we have integer servo equals 7 to pin 7. And then we have a integer of angle, integer of PWM for our pulse width modulation. And then we have our integers of LED pin going to equal to 13 to LED pin. That will be our LED to pin 13. And then we have our constant integer for our buzzer, because here we are adding the LED as one of our components and a buzzer as our other component for adding 2 for the attempt A. So we have a constant integer buzzer equal to 9, so that's setting the buzzer to pin 9 to get its output. And we have our void setup, which will end the initial setup, and after that we have our functions, our pin mode servo to output, pretty much giving the pin 7 output, so that when it wants to give signal to the servo, it'll output and give an output signal to the servo motor. Pin mode buzzer output, and this one's going to give output from pin 9, because our variable buzzer is set to pin 9, so it's going to give our output to pin 9 for our buzzer to give our signal as far as when it wants it to do what it needs to do. And then our last one is a pin mode LED output, and this one is the just pretty much setting an output signal to pin 13 as our output for our LED. Next is our void loop, and this is where we will be starting our loop function. And pretty much in this piece of code here, we'll be using the for loop, and we'll be using our angle, our variable angle equal to 0. Angle is less than or equal to 140. Angle plus 5, or I'm sorry, plus equals 5. And then we have our servo post, servo angle, and for angle 140. Angle is less than or greater than and or equal to 0, and then we have our angle minus equals 5. Servo post, servo angle. So pretty much what this will be doing is taking our servo from angle 0 to 140, and then back from 140 to 0, and it's going to be running that in a for loop for both of those there. It'll finish the first for loop and then run the next for loop. And then our next piece of code is going to be our digital write LED pin high, and this is going to turn our LED pin on, give us the buzzer, because at this point on the first for loop section here, we have it going up, and on our servo motor is going to be pointing up, and then we're going to have our LED go off, and when our LED turns on, the buzzer is going to turn on at the same time, and we have our coding for that. Tone buzzer 1000, and that's pretty much going to send a 1 kilohertz signal, and then we're going to have a delay of it on for approximately 1 second, and then no tone buzzer, where it'll stop the sound and be off for approximately a tenth of a second, or a very small short delay time. And then our digital write LED pin low, which will turn the LED off. So in theory, it's gonna, on our first sets of 4 loops, they're gonna make the little arm go to a certain spot up, and then we'll be going with our LED on with our sound, and then LED off, and then we're gonna go to the next piece of code, which are be our void servo posts, integer servo, integer angle, and then we're gonna have the PWM equals angle times 11 plus 500, and that's going to convert the angles into microseconds, and it's going to be our servo high with our delay microseconds PWM, digital write servo low, and delay. And this is going to be our code that's going to be pretty much calculating the actual seconds that it needs to spin the motor. And then we have our delay of 100, which is just a very slight delay, and I did that delay so that it can move the arrow a little bit slower to give us a more realistic look. Excuse me. And that's just so it's not spinning real high and going fast. And what in this project here, I'm going to go ahead and go over the Arduino itself. And on the Arduino, we have it the servo motor pretty much hooked up the same way, and nothing changed as far as the motor itself being hooked up, and our motor is hooked up here to pin 7, and then we do have our buzzer hooked up to pin 9, and we have the negative hooked up with the 220 ohms resistor for our buzzer. And then our LED is connected here. We have the wiring going to our LED, and I'll show you that right now. And the LED negative is going to be connected with a 220 ohms resistor, and then we have the positive going to the LED itself. And as far as making something meaningful or making it do something meaningful on this project, we are doing a risk meter, where I have our servo motor hooked up to, it's a piece of cardboard that has some construction paper taped over it with a cutout, and we have our arrow, and pretty much it's a risk meter, and it's gonna detect the level of risk, and we have a low level of risk or medium level of risk or a critical risk level. Then our little indicator will let us know when we get to the critical level. It's gonna also as well give off the LED letting us know that we're on that high critical, and it'll alert with the sound as well. So we'll get the sound and the LED alerting us that there is an issue or a malfunction or something going on that we need to be aware of. And I'm going to go ahead and plug up the Arduino and get this going, and we will upload here on the steel here. Hit upload, and we're going to send it. It's going to compile and send it to the Arduino, where we will get the send and receive, and then we have our Arduino going. We're at low risk, medium risk, and then we get to a critical risk, and we get our light that goes off, and our buzzer goes off at the same time. And like I said, I had the slight delay to kind of give us that little bit of the arrow to slow down a little bit, so it's not going real fast, just for display purposes. But this is my attempt A on Circ 04, and thank you.